USB plugs have a strange rule. They almost never go in the first time. But this isn't bad luck. It's actually part of the design. You've probably experienced this. You pick up a USB cable, you move it toward the port, you line it up carefully, and then it doesn't go in. So you flip it over. Still wrong. You flip it again. And somehow, now it works. It feels almost like the USB port is playing a trick on you. In fact, there's a joke that circulates around the internet. A USB plug has 3 sides. Wrong, wrong again, and finally, right. But here's the strange part. This experience is so universal that engineers and designers know about it. Millions of people around the world struggle with the exact same tiny moment of frustration every day. In offices, in bedrooms, in coffee shops, in airports. And yet, USB connectors were designed by some of the smartest engineers in the tech industry. So why would they create something that seems so inconvenient? Why does it feel like USB plugs never go in the first time? Is it bad design? Or is there something much more interesting hiding behind this everyday annoyance? To understand the answer, we need to go back to the moment USB was invented. Before USB existed, connecting devices to a computer was a nightmare. Take a look at the back of a computer from the 1990s. You would find a confusing jungle of ports, serial ports, parallel ports, PS2 connectors, game ports, SCSI connectors. Each one looked different. Each one required a different cable. And most of them had something in common. They were huge. Some used screws to lock them in place. Others had dozens of tiny pins that could bend if you weren't careful. Plugging in a printer or camera often meant crawling behind your desk and guessing which port was correct. Even worse, many devices required restarting the computer after connecting them. So in the mid-1990s, a group of companies decided to fix this mess. Companies like Intel, Microsoft, IBM, and Compaq came together to create a new universal connector. Their goal was simple. One port, one cable. Plug and play. No confusion, no restarts. This new system would be called USB, Universal Serial Bus. But creating something universal came with a tricky design challenge. And that challenge is exactly why USB behaves the way it does today. At first glance, a USB plug looks simple. Just a small rectangular metal connector. But inside that tiny piece of metal is a surprisingly complex design. Engineers had to solve several problems at once. The connector needed to be cheap to manufacture, durable enough for thousands of uses, small enough to fit on laptops, strong enough not to break easily, simple enough for anyone to use, and most importantly, it needed to connect power and data safely. Inside a USB connector are multiple metal contacts. These contacts must align perfectly with the ones inside the port. If they connect incorrectly, the device might not work. Or worse, the hardware could be damaged. So engineers made a crucial decision. They designed USB connectors to be directional. That means the plug only works one way up. At first, this might sound like bad design. Why not make it work both ways? But remember, the first USB connector was designed in 1994. Computers were very different back then. And making a reversible connector was far more complicated than it sounds. To understand why, we need to look at what's happening inside the plug. Inside every traditional USB plug is a small plastic piece. Engineers call it the tongue. This tongue holds the metal contacts that transfer power and data. When you insert the plug into the port, this tongue slides inside the connector. The contacts line up. Electricity flows. Data begins moving between devices. But this system only works if everything lines up perfectly. If the connector were reversible, engineers would have needed to duplicate all the contact points. That would make the plug more expensive, more fragile, and much harder to manufacture in the 1990s. Cost mattered a lot. USB needed to become a global standard. That meant billions of connectors would be produced. Even a tiny increase in manufacturing costs could add up to millions of dollars. So engineers chose a simpler design. One direction, one internal structure, one inexpensive connector. This decision made USB cheap and reliable, but it also introduced a tiny usability problem. The plug only works when it's facing the correct direction. And that brings us back to the strange phenomenon everyone experiences. Why does it feel like the first try is always wrong? Here's something interesting. Technically speaking, you should be right 50% of the time. There are only two possible orientations, so half the time the plug should go in on the first try. But most people feel like they're wrong almost every time. Why? The answer has more to do with psychology than engineering. Our brains remember frustration much more strongly than success. When the plug works immediately, we barely notice. But when it fails, our brain stores the moment as an annoying memory. This is called negativity bias. Humans naturally remember negative experiences more vividly than neutral ones. So over time, our memory builds a false pattern. We begin to believe USB plugs never work the first time, even though statistically, they often do. But that's not the only reason this problem feels worse than it actually is. There's another design detail involved, and it's hiding on the top of the connector. Take a look at a USB plug. On one side, you'll usually see something printed on the metal or plastic. Often it's the USB symbol. Sometimes it's just a brand logo. But that marking isn't random, it's actually a hidden guide. In most devices, the logo side should face upward when inserting the plug. That small symbol is meant to tell you the correct orientation, but there's a problem. Many USB ports are located in places where you can't see them clearly, behind computers, under desks, inside dark laptop ports. So the visual clue becomes useless, you're forced to guess. And when people guess, they're wrong half the time, which leads to the familiar flip plug ritual. But interestingly, engineers eventually realized this frustration, and they decided to fix it. In 2014, a new connector was introduced, USB-C, and it solved the problem completely. USB-C plugs are fully reversible. It doesn't matter which way you insert them, both sides work. Engineers achieved this by redesigning the internal structure. Instead of a single row of contacts, USB-C has multiple mirrored contact points. This allows the connector to function regardless of orientation. But this new design is also more complex. It required advances in miniaturization and manufacturing, which simply weren't practical when the original USB standard was created decades earlier. Today, USB-C is slowly replacing older USB connectors. You'll find it on modern laptops, smartphones, and tablets, but billions of devices still use the original USB Type-A connector, which means the classic flip plug moment will probably stick around for years. And strangely enough, that tiny frustration became one of the most relatable experiences in modern technology. It's easy to look at USB plugs and think they were poorly designed, but the truth is almost the opposite. The original USB connector succeeded because it was simple, cheap, durable, reliable. Those qualities allowed USB to become one of the most successful technology standards ever created. Today, there are billions of USB ports around the world. On computers, TVs, cars, game consoles, airplanes, that tiny rectangular connector helped unify the entire tech industry. And yes, it occasionally makes us flip the cable twice before it works. But that tiny inconvenience is the result of a design choice made nearly 30 years ago, a choice that prioritized reliability and global compatibility. So the next time your USB plug refuses to go in on the first try, just remember, it's not broken, it's not random, it's simply the legacy of one of the most successful engineering decisions in modern technology. And once you notice the hidden logic behind everyday objects, you begin to realize something surprising. Even the smallest designs often have the biggest stories behind them.